Hi, I'm Darius Lee, and I'm a senior here at Intercom High School. I'm going to be teaching you how to do related rates from calculus. Okay, so our problem today is a water trough is 12 feet long, and its cross-section is an equilateral triangle with the sides of 2 feet. The sides are 2 feet long. The water is pumped into the trough at the rate of 3 cubic feet per minute. How fast is the water level rising when the depth of the water is 0. feet deep? Okay, so this is all the work I ended up doing. And I trimmed it down to this. A lot neater, right? Okay, so we write down first what we were given. So we're given that the change of the volume is 3 cubic feet per minute. We're also given the height of how deep the water is, which is 0.5 feet. We're also given the width, which is 2 feet. The length of the trough, which is 12 feet. And we're also given the well, this is given after we solve a couple of things, so just ignore that for right now. So right now, we're trying to find the change of the height within the water when it's already at 0.5 feet. So what equation we decided to use is volume is 1/2 base times height times length, and so we have H, but we have no idea what B is, if you ignored what I showed you up there. So we can go divert our attention to this example of drawings. We drew that the trough, what the trough length and the trough width is, but we still don't know what the base is. So what we do is we go to the triangles, and by using the 30, 60, 90 rules that we learned from previous math classes, we can end up finding that after you do the Pythagorean's theorem, which would result in the h being square root of 3, you can find that b is equal to the 1/3 height. Now, going back to this. Now that we know all of that great information, there we go. After that, we can decide to take the derivative. Well, let me back up a second. First, we have to plug in all the things that we can so we can simplify it, or you can leave it out, but I'd like to put the stuff in. So, L is 12, so you would multiply that by 1/2, which would be 6, and then B, as we said, is 1/3 h, so we would plug that in, and we get 2h squared. Okay, and then after that, you take the derivative of the equation, which would be dv dt, which we do have from the given information, which is equal to 4h dh dt. Now, after that, we have to get dh dt by itself, because that's what we're trying to find. So what you would do, you would divide 4h from this side, so you can get dh dt by itself. And since h, as we found from this problem over here, is equal to the square root of 3, we could plug it into this equation here, where h is. And then, since it's a lot better if the square root's not on the bottom, you multiply both sides by square root of 3. The 3 cancels from the square root of 3 times square root of 3, which is 3, and there's already a 3 on top, so those cancel, and then you multiply the square root of 3 on top of this, but that one stays, which results in the answer, square root of 3 over 4 feet per minute. Okay, so I hope that wasn't too fast for you, but that's how you solve a related rate problem. Thank you, Ray, for helping.